Solving log equations. So we've already solved some exponential equations using logs, and that technique is going to come in handy here. From log expressions, I've still got my log rules, which I'm going to be using here. You can see log x plus log 4, which one am I going to use here? So let's get started with that. So I'm looking to find for the solving equation x equals. So the first thing is I'm going to use my log rules here. This is going to give me log to the base a of x times 4, well that's just 4x, equals log to the base a of 8. Now if you watched the last video on breaking down log relationships, if the log to the base a of 4x is equal to log to the base a of 8, log of this equals log of this, then this must be equal to this. In other words, the log on both sides cancel. Please note that we can only cancel logs when you've got log and log, a single log containing everything on both sides. We can't just look here and say cancel log, cancel log, cancel log. So that gives us 4x equals 8, and we can quite easily solve that. Divide by 4 to get x equals 2. One final thing that's very important to do when we solve a log equation is check that our answer for x is consistent with our logs. Now earlier on I mentioned that you can't take the log of a number which isn't greater than 0. In other words, you can only take the log of a positive number. So if you look inside the log and the value of x means that is either 0 or less, then actually, even though we found a valid answer, it actually doesn't work, and we have to say that it's inconsistent and rule it out. However, here when x is 2, we get log to the base a of 2. That's totally fine, therefore this is our solution. Note that I'm not actually writing anything here as long as it works, but that is what I'm thinking at the end of every log equation. So here we've got another log equation to solve, so we're looking to get x equals for our answer. So first of all, looking at the left hand side here, well, I can use my log rules. Log 2 of this bracket, take away log 2 of this bracket. It's really tempting just to push these together, but take away means I'm going to divide them. So this becomes log to the base 2 of 3x minus 5 over divided by x plus 2. And that is equal to 1. So my first slight change here is, compared to my last example when I had log and log on both sides and I could just cancel, on the right hand side I've just got a numerical value. So there is something I can do to make it like my last question, which is to ask, what can I write 1 as in terms of log to the base 2? So in other words, log to the base 2 of something, I want that to be the same as 1. If we have a think about it, log to the base 2 of 2, well, that's equal to 1. So there's nothing to stop me changing 1 into log to the base 2 of 2 and now cancelling. That's an option. However, I'd like to show that we can do it a different way as well. And this is very, very similar to solving those exponential equations. In other words, I want to get rid of this log to get the x on its own. Ultimately, I'm going to grab this log to the base 2. I'm going to take it across, and the opposite of the log to the base 2 is an exponential to the base 2. So this is going to be gone. On the left hand side, I will have this. Brackets no longer needed. And on the right hand side, well, the opposite of a log to the base 2 is an exponential to the base 2. So 2 becomes a base, and that 1 gets pushed up as a power. I can leave that there, or I can say, well, 2 to the power of 1. That's just the same as 2. There we go. So I can solve it even though I've just got 1 log on one side by bringing it across. So the rest of this question involves getting this x plus 2, getting it out from under there, so it's going to come across and be a times. So 3x minus 5 is equal to 2, and I'm going to need a bracket here, x plus 2. We're going to very, very quickly solve that. 3x minus 5 is equal to 2x plus 4. Take my x's to the left, 3x minus 2x is x, 4 plus 5 is 9. And the final thing I'm going to do is I'm going to have a look at this 9 and I'm going to say, does this 9 work for my logs? Well, what is 3 times 9 minus 5? That's 22. Log of 22 is fine. What is 9 plus 2? Well, that's 11. Log of 11, well, that's totally fine. The only thing that wouldn't be fine is log of 0 or log of a negative number. So that's that example done. Okay, so final log equation is this complicated looking thing. What I would say is that when we come to copy this down, take your time. I just had to redo this because when I copied it down, I accidentally forgot the x there, which completely changed my question. So, first of all, looking at the left-hand side here, I'm going to put together these two logs. Adding means it's going to become multiplied together inside a log. So log of 2x plus 1 brackets 3x minus 10 equals log to the base a of 11x. Now, log of this is equal to log of this, therefore these must be equal. In other words, cancel logs on both sides. Leaves me with 2x plus 1 brackets 3x minus 10 is equal to 11x. I'm going to multiply this out, move it all across, I'm going to factorise it, I'm going to come up with my two solutions, so let's fast forward to that. Okay, so I've got my two solutions. X is negative a third or X is 5. Now there's nothing in itself wrong with X being a negative number. What is important is that when X goes into these, that the logs that we're taking are logs of numbers bigger than 0. So if X is 5, let's start here. We can see this one's going to be fine. 2 5s plus 1 is 11. Log of 11 is fine. 3 5s minus 10 is 5. Log of 5 is absolutely fine. However, minus a third, well, have a look here. 2 lots of minus a third is minus 2 thirds. Minus 2 thirds plus 1 is a third. Log of a third is actually fine, so there's no issue with the x being negative in this one. However, when we take the x and look in here, we find that 3 lots of negative a third is minus 1. Take away 10 is minus 11. We can't have log of a negative 11. So therefore, this solution, and the same will apply here, this solution is actually inconsistent. Even though all our algebra is correct, we've simply got to say that this is not consistent. Just got to say, spelling properly this time, that this is not consistent. With the logs we are given, or not consistent with logs. Crossed out, that's our only valid solution.